In lesson 8.3, day 2, we're going to focus in on some compound interest formulas in the context of finance. If you have a bank account, whether it's a checking account or a savings account, you'll notice that you will receive interest from that institution, from that bank. This formula can be used to help us find the balance that you will have when interest is added in. Look at this formula here. A equals P times parentheses 1 plus R over N to the NT power. A is the total value of the investment at time T. P is the original value of the investment. It's called the principal, and it's what we start with. This is the value of your investment when you open up your account. Just as we saw yesterday with interest rates, which is going to be given to us as a percent, when we had a percent on day 1 of 8.3, we'd always change that to a decimal. R is your annual interest rate. We're going to have to do that as well. Change it to a decimal. N is the number of times per year that interest is compounded. Now this is where it can get quite a bit different. If you have monthly compounding, there are 12 months in a year, we would have N equals 12. If you have quarterly, just like there are 4 quarters in a dollar, there are 4 quarters in a basketball game, you would have 4, N equals 4. Interest would be given to you 4 times a year. So you might have a savings account. You would get a statement 4 times a year stating what your new balance is, reporting what interest was given to you. T is the amount of time that has passed in years. So this is the formula that we're going to be working with. I'm actually going to give it to you on our next quiz. And what we have is also one other very big word of caution. The exponent in here, the NT, we're going to write in parentheses. The fact is, this exponent that you're seeing, the NT, both the N and the T are raised up as a power. So if we're going to type this in using a calculator, of course, we need to ensure that both of those are raised up as an exponent. Let's jump into a couple of problems. We're going to skip the continuously compounded interest formula. I've crossed that box out. But just look at example 1. And again, we could state what this formula is. It's A is equal to P times 1 plus R divided by N. Raise that up to the NT power. Well, an investment broker in this problem deposits $1,000 into an account. That seems to say this is what we're starting with. This is our principal. P would equal 1,000. Your account earns 2% annual interest. Now this 2%, you could do this a couple different ways. 2%, anytime we have a percent, we'll move our decimal 2 places to the left. Our R would be written as 0.02. Now another way you can think about this, even the phrase percent indicates divide by 100. Per would indicate division. Cent, we know that prefix to refer to 100. So if you ever are doubtful if you've done this right, you can just say 2 divided by 100. Of course, you'd very quickly see that's 0.02. Compounded quarterly. Well, this means our N, just as we said before, 4 quarters in a dollar, 4 quarters in a basketball game, N, of course, would equal 4. And what is the value of this investment after 10 years? Well, of course, this would lead us to say that T is equal to 10. All we have to do, very simply, is substitute all of these terms into our formula and then plain and simply work this out. we can allow the calculator to work this out for us. Up on top here, this n times t, 4 times 10. Of course, we know what 4 times 10 is. It's 40, and we could even very quickly simplify that. But look, very often we just type directly into the calculator. Let me clear this up and see what we will get. 1,000 parentheses 1 plus 0.02 divided by 4, and we'll close our parentheses. Now, at this point, what you're going to see if you don't have the latest version of the graphing calculator, when you hit the caret button right above the division, you will actually see a caret, this symbol right above the division button. However, my calculator is a little bit more advanced. It's got the latest software on it, so it actually raises up to where an exponent would be written up high. I'm still going to put in parentheses 4 times 10. Now, of course, we could more simply just say that that's 40. The directions here say what is the value of this investment to the nearest dollar. Evidently 1,221. 1,221. So that's about what we have to the nearest dollar. So really what I'd like to also point out just what this would have looked like if you were just typing it into a calculator that didn't have that other version. What you would see, of course, you'd have this, then you'd say caret, you'd actually see the caret symbol there, and then we type in parentheses 4 times 10. Work that out, of course, and you get the same answer. Alright, one more problem and then we're through. Very similar, by the way. We're going to use this same formula, and we just have to interpret this and work out all the details. An investment of $3,000. Well, hey, that's what we start our account with. That's our principal. That's P. It's placed in an account that earns 1% interest. It's so tempting to write R equals 1, but again, we must write this as a decimal. If we took 1 and if we moved our decimal 2 places to the left, we would get 0.01. The other option is to take your percent of 1 and divide by 100. 1 divided by 100 would give you 0.01. We are compounded monthly. N in this regard is 12. And we'd like to know the value after 5 years, so we're going to let T equal 5. Very quickly, hopefully you're getting the catch here. 3,000 goes out in front. 1 plus 0.01 divided by 12. Again, be careful with this exponent. Honestly, there are two main mistakes that are made. One huge mistake is not to have parentheses up by the exponent. The 12 times 5, which of course more simply is 60, is your power in this formula. But if you're just typing it out exactly as we've done right here, you need to have parentheses around that. So let's just do that, typing in 3,000 parentheses 1 plus 0.01 divided by 12, and raising that up to the, now we could just type in a 60 and make it very, very simple. Sometimes things might get a little bit more complicated though, and it might be just as easy to type in 12 times 5. 12 times 5, of course, would be 60, but in the end here we'll see that our balance is about $3,154. $3,154. So that would be our balance, including some interest. You can see in this 5 years, the bank has given us $154. One more additional thing that we should refer to. I mentioned before sometimes the exponents are more complicated where you wouldn't want to just multiply out by hand. There is also daily interest, daily compounded interest. Sometimes that does sneak in. Obviously, there are 365 days in a year, and in that regard, n would be 365. Certainly, if 365 is there for your n times t might be a little bit more difficult to work out, and in that regard, you certainly would want to just type it directly into the calculator. Well, I hope this helps. Definitely good luck, and come see me if you're having any trouble.